speed. But I handed out the packet and we went over it earlier and people were trying to do stuff and not paying attention. So pay attention to me on this and then I'll give you the rest of the information. So yesterday you guys took and created scatter plots on Alex. And you told me whether they had a linear or nonlinear association and whether it was positive, negative, or no association whatsoever. So to expand on that, we're going to talk about identifying lines of best fit. When data are collected, the points graphed usually do not form a straight line, and we talked about that yesterday. They're not going to line up right in a row, but they still can approximate a linear relationship, meaning it's a linear trend. There's not a hook or a curve to it. So today we're going to talk about a line of best fit. Is a line that goes through the center of your data and is close to most of the data points. It doesn't have to touch a single data point, but it has to be close. It's going to model the relationships between the two variables. To draw a line of best fit, draw a straight line so that about half of the points are above the line and half of the points are below the line. You want it to be central. If most points are close to the line, it's a good fit. If most points are not close to the line, it is a poor fit. When drawing the line of best fit, you can ignore the outlier. Remember, an outlier is a point that doesn't match the rest of that data. So you just ignore it. Okay? Like, oh gosh, that guy's way far off. Don't try to get your line by there. So when you take your points, you're going to draw the line and assess it. Is it a good fit? Is it not a good fit? If it's a good fit, yeah, I have a linear relationship. If it's not a good fit, double check you drew your line well, and then it may not be a linear relationship. All right, let me get to the rest of these notes. Pass the message along. Okay, so we're on this. My bad, I forgot to get that. Apparently got missed when I sent them to get copies. So the table shows the average traffic volume and average vehicle speed on a highway in a week. Part A, construct a scatter plot on the graph provided and use a ruler to approximate the line of fit. I have a scale written on there for you. Starts at 5,000, correct? And then it starts at 30, is that right? Okay, so take these points and plot them on that graph. Now, it's going to be an approximation. It's not going to be perfect for all of them. Your point should look very similar to mine when you get yours done. All right, so now you have a ruler on your desk, and it's nice that it's clear so you can see through it. You need to, don't draw a line yet, but you need to place it through the center of your data. It does not have to go through the origin, where there about half of the points are above the line, half of the points are below the line. You don't even have to have a single point touching the line, but your line needs to be the best representation of that data. So swivel that baby around as far as you can get there. So if you did something like this, is that a good representation? It is? How many points are above my line right now? 2. How many are below? Yeah, and there's like one right here, right? You want this to be right through the center. So take a minute and using your ruler, draw a line that gives you the best representation of your data through the center. Now mine is never going to be as good as your guys's because I can't use a ruler. But it should be something along these sorts. Okay. Would you say that most of those points are close to that line? I would say yes. So would you agree this is a linear representation of data? So when it says assess the line of fit, you would say the line of fit is good. So this data is linear. The line of best fit is good. So this data is linear. If it's not linear, it's going to hook dramatically. You draw a line through it, and you're going to say, yeah, the line of fit is not good. It is not linear. Okay? So it's going to be a distinct hook or curve. What are we going to ask?
When did you say that the data is linear?
Because it wants you to assess the line of fit. That's how you assess it. You're telling me it's a good line of fit, so the data is linear. Now, what does a line of fit actually do for us? So in this next one, it can help us make conjectures, or in other words, educated guesses or projections about data that maybe isn't included on our graph. So the scatter plot shows the distance traveled down here on the X and the cost of an airline on the Y. How can you use the line of fit to make a conjecture or an educated guess about the cost of an airline ticket if the distance traveled is 1,300 miles? So we know we have 1,300 down here. So if you look at your graph, it might be kind of hard to see on yours. They have 1,300 traced all the way up to this line. Where it meets the line, then they take it back to the y-axis, and you would say 1,300 miles. What do you know about it? It's going to cost $275. So the question says, how can you use the line of fit to make a conjecture about the cost of an airline ticket if the distance traveled is 1,300 miles? Traveling 1,300 miles will cost approximately $275. We use the word approximately because this is a line of best fit. It's not the guaranteed price. It's a projection. It's a conjecture. So you're going to write the word approximately today when you're talking about using that line of fit. When you draw it, it doesn't even have to touch a point. It has to be like, if you look at this one, it barely brushes here. But you want it to be the best representation through the center of that data. Okay? Flip it over. On your own. I'm going to read this out loud to you. On your own. The scatter plot shows the amount of money earned by different servers at a restaurant and the number of tables they served in a week. Use the line of fit that is drawn to make a conjecture, that's your educated guess, about the amount of money a server will earn if they serve 225 tables in a week. On your own, and then we'll talk about it. This one's not quite as straightforward, agreed? If I take 225, it's right on this line. I take this grid line all the way up. Where it crosses that line is not directly on a grid line. So if you wrote 1,000 or you wrote 1125, I'm counting that wrong. What should you guess? Or what should you use as a conjecture? 1,100? I argued that earlier today, but I would probably take it. 1,000, 1,075. Somebody this morning said 1,050. More so, it's got to be between 1,000 and 1125, but not either one of those because it is not on those grid lines. Follow me? So sometimes scatter plots, because it's an approximation, you're going to have different answers. So you would say a server serving 225 tables will earn approximately $1,075 or $1,100 or $1,050. Don't put 1,000. Don't put 1125. Bless you. Here's the deal, and here's how Miss Hoff gets super frustrated in this chapter. So many times in other problems and everything we've done this school year, there's been like a line of directions. Solve the equation. Find the volume. Write the equation of the line. And it's been those directions for everything. So you haven't had to do a lot of reading. Well, in chapter 9, information is given to you in this writing. I want to call it a paragraph even. It's going to tell you what you need to do. And many times it's more than one thing. So I'm going to reiterate to you the importance of reading the problem to know exactly what is asked of you. Okay? You have 8 problems for homework and the rest of the hour to work. I'm going to leave this up here so you have an example of what your sentences should look like. If you get done, keep it, and then you can work on other homework. We will correct it on Monday.